All right, well, good morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Warm up 112 is on the screen. So I'm giving you practice, bless you, the binomial probability, what we just did yesterday. Last week, sorry. And see how you do with that. And we'll go from there. Copy it. All right. Should be done with that. Share with your neighbor your warm-up, please. Bell curve, Z-score, and the probability that they got for those wedding destinations. All right. Good. So, with that said, copy the agenda, please. Warm-up of 112 is done. Today we are going to complete the discrete probability distribution section. We're about to embark on the last section that we're going to cover for the school year. Not today, though, but today we're going to finish discrete probability. And tonight's home play, only two problems. Only two problems. All right, so the only home play that you had last night, tell your neighbor what it was, please. No. Go to Canvas, turn in your signed screenshot, please. Do that right now. Pop cart tag, let's go. Then copy the code for your home play access, GXC5H, GXC5H, GXC5H. All right, thank you for turning that in. Here we go. Our objective for today, I can define and compute discrete probability distribution. We're in the tail end of this. So where have we been? Well, let's see. Started with all the different areas of probability. We went into random variables, and we said they were concrete and continuous. From there, we went into the probability distribution. We were going to know what that looks like. From there, we went to the mean, variance, and standard deviation for the probability distribution. From there, we went into binomial distribution, gave you guys a formula for that. So, notice that we went from a single to a double, which is a binomial distribution. Guess where we're going next? Single, double. Yeah, multinomial. Write that down, multinomial distribution. That's when we have not two exact probabilities. This is going to be more than two. Okay. So, multinomial distribution. And it says this, blah, 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 but just copy the formula. P of x equals n factorial over x of 1 factorial times x of 2 factorial, x of 3 factorial, dot, 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 all the way to x of k, times probability sub 1 to the x of 1, probability sub 2 to the x of 2, dot, 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 probability of sub k to the x of k. And it says here that x of 1, x of 2, x of 3, all these are the total n. And P1, P2, P3, all the way to Pk, they add up to 1 because they're probabilities. All right, shall we? All right, here we go. Copy this example on your paper. This is the only one that you're going to copy for today, just so that you can have one as an example of the multinomial distribution. And it reads, example Q. In a large city, 50% of the people choose a movie, 30% choose dinner and a play, and 20% choose shopping as a leisure activity. If a sample of 5 people is randomly selected, find the probability that 3 are planning to go to the movie, 1 to a play, and 1 to go shopping or to the shopping mall. Copy that. I'm going to leave the formula down here so we can use that for this example. Use some time. Copy it. All right, shall we? So, to get started, we always start with our n. So write your n on the side, n. However, for this one, instead of being 1 or 2 probabilities we're looking for, now we have 3. 3 are planning to go to the movie, 1 to a play, and 1 to a shopping mall. And there's 3 different ones. That's why it's called multinomial probability. So that means we need x sub 1, x sub 2, and x sub 3. And for each of those x's, we need its corresponding probability. So leave an empty space, and over here on the side, we're going to write P1, P2, and P3. And the good thing with these is that they already give us the probability ahead of time. We just need to make sure that we see it and we read it on the problem. So here we go. So I'm going to use red to get started. So what's the first x that we're looking at? Well, the first x is what? That 3 are planning to go where? To the movie. So underline that in red. That's going to be our x sub 1. But we need a corresponding probability. So let's read this from the top. In a large city, 50% of people choose a movie. So what would be the probability for these 3 to go to the movie? Everyone? How do you write that as a P? What is it? Yeah, 0.5 or 0.50. I'm going to switch to blue. What's my next probability? 1 to a play. So my next x is 1. So what is the probability of people going to a play? What says here? 30 choose to go to dinner and a what? Play. So how do we write that as a P? Point what? 30 or 0.3. That is correct. And of course, last but not least, 1 to the shopping mall. And what are they going to be doing at the shopping mall? Well, it says here 20 choose to go shopping at leisure activity. So we write that as 1. And what is its probability? Point what? 0.2. Are we there so far? Okay. And the rest is history. We take our formula, fill in our formula. Start off with P of x equals blank factorial. And we go with n. What is n for our factorial, everyone? How many total people? 5. So that goes right here. Bless you. Next, we need all of these in factorial form, all the x's. So we're going to write x sub 1, which is 3 factorial, times 1 factorial, times 1 factorial. Which are which ones? These, right? All the n's. Bless you. So far so good? Times. Now we need our p to the x. Look up. So I'm going to go with my first p and then the x. So what is p? 0.50 or 0.5 to what exponent? Everyone? 3. That is correct. Times the next one. 0.3 to the what? To the 1 times, last one is 0.2 to the 1. All right. Here we go. This is 5 times 4 times 3 factorial over 3 factorial, and then 1 factorial is just 1, is that correct? Yeah. Times 0.5 cubed times 0.3 to the first times 0.2 to the first. So this one, there it is. So we end up with P of x equals 20 times 0.5 cubed times 0.3 times 0.2. Calculators calculate, please. All right, looks like Dylan's got it. What'd you get, Dylan? 0.15. That is correct. Let's write this in percent, since we started with percent. So what is the percent of these 5 people going, 3 to the movie, 1 to play, and 1 to the shopping? It's 15% probability. Pretty straightforward, yes? Yeah, all we need to make sure is how to match the x sub 1 to their p's, x sub 2, x sub 3, and so on and so forth. All right, let me send you the screen so you can send me your notes. All right, and just in passing, look up to the screen. Just remember that all the x's, whatever they amount to, if there's x sub 4, x sub 5, whatever the amount of x's, all of them, if you add them up, need to add up to what? Need to add up to what? To the n. 3 plus 1 plus 1, that is 5. So if you have another problem that has x sub 4, x sub 5, x sub 6, all those numbers need to add up to the n. That's one thing. The other one is that all the probabilities need to add up to 1. That is correct, 1. So make sure you keep that in mind in case you're missing some percentages. There it is. Okay? All right, with that said, copy, don't copy this one. This one we're just going to start from the n, x sub 1, x sub 2, x sub 3, and its corresponding p's. And I read, bless you, example mega cube. It says, a small airport coffee shop manager found that the probabilities of customer buys 0 coffees, 1 coffee, 2 coffees, or 3 cups of coffees are 0.3, 0.5, 0.15, and 0.05 respectively. Remind your neighbor what respectively means. What does respectively mean? What does that mean? Not that they're being respectful. I'm saying respectively is that in that same order, the x's should match all the probabilities. That's what it means. They should be able to match. So, if I was to start with my n, let's start everybody with our n over here. All right. So, what is our n, everyone? Yeah, that is correct. 8 customers, so that is 8. And then this time we have how many different types? We have, let's see, 1, 2, 3, and 4. 4 different x's. So x sub 1, x sub 2, x sub 3, x sub 4. And with its respective probability, P1, P2, P3, P4. All right, so let me pause the music in the back. So let's go with our first one. It says, find the probability that two will purchase something other than coffee. So my first probability that I need to look for, or my x, is x sub 1 is my 2. So what does that represent? 2 will purchase what? Something other than coffee. So what does that mean according to what we have here? Look at it. Let me read it again just to make sure you got it. A smaller coffee shop manager found that the probabilities of a customer that buys 0 cups of coffee, 1 cup of coffee, 2 cups of coffee, and 3 cups of coffee. So what does this mean? 2 will purchase something other than coffee. Which one corresponds to that? Yeah, 0. That is correct. So this one corresponds to 0. So which is its probability if it says here that it respectively, sorry. So 0 corresponds to what? 0.3. That is correct. So we write 0.3. You're like, ooh, okay. Let's go with the next one. 4 will purchase 1 cup of coffee. 4, I'm going to write 4 here. So 4 of them. 4 will purchase what? 1 cup of coffee. Where's 1 cup of coffee? Right here. And what is its probability? 0.5. Next, 1 will purchase 2 cups of coffee. So 1 will purchase 2 cups of coffee. So let me underline that with green. 2 cups of coffee. Where's 2 cups? It's right here. And what corresponds to that one? 0.15. That is correct. So far so good, yes? All right, and last but not least, 1 will purchase 3 cups of coffee. So 1 will purchase 3 cups of coffee. Where's 3 cups of coffee? Right here. And what's its percentage or its probability? 0.05. 0.05. Yes? All right, so now that we have all our labels, use the formula, set it up. Here we go. P of x equals n factorial, so that is 8 factorial. Then all our x's. So we got 2 factorial, 4 factorial, 1 factorial, and 1 factorial. All right. Times. What's our first P? Our P is 0.3 to the what? To the second power. Times. Next one. 0.5 to the what? Fourth power. Times. Next one. 0.15 to the first power. Times. And last but not least, 0.05 to the first power. All right, P of x equals, let's see, we have 4 factorial, so I'm going to do 8 times 7 times 6 times 5 times 4 factorial over 2 factorial, so that's 2 times 1 times 2, so I'm just going to write 2 times 4 factorial times 0.9, because I did the 0.3 squared, times 0.5 to the fourth times 0.15 times 0.05. So this is a giant 1. P of x equals, let's see, 5 times 6 is 30. Yes? What is 3 times 8? Did I skip something? 0.3 squared, oh no, oh yeah, my bad. Yeah, I did that to see if you were paying attention. Thank you, Dylan. 0.09. Where was I? 30. So 3 times 8, that's 240 times 7. 240 times 7, 082. 2, 14, 16, divided by 2, that's 840, times 0.09 times 0.5 to the fourth, times 0.15, times 0.05. All right, let's see what you get. Calculators calculate. Looks like Lenny's got it. Very good, Lenny. What you get, Briseida? 0.035. I'm going to leave it at that. And in percent, that is 3.5%. All right, let me send you the screen so you can send me your notes. There it is. So on this one, the only thing that you need to really focus in on identifying what they're asking, going to its original, and then matching to its probability. All right, so far so good. We did example Q. A little bit more straightforward. It was just like the X and the P, straight from there. This one required, the second one required a little bit more digging in regards to writing these as our X's and then matching them to its, what the manager saw and its probability. So, with that said, look at this one and it says, a box contains 4 white balls, 3 red balls, 3 blue balls. A ball is selected at random and its color is written down. It is replaced each time. Find the probability that if 5 balls are selected, 2 are white, 2 are red, and 1 is blue. All right? So, talk it over to your neighbor. Let them know what N is for that one, and what your X of 1, X of 2, X of 3, and your probabilities for those are. Oh, sorry. My bad. Let me send that to your screen as well. All right, let's start with N. What is our N, Diego? It says find the probability that 5. That is correct. Write that down. N equals 5. So, what is our X of 1, X of 2, and X of 3? Tell your neighbor what they are. X of 1, X of 2, and X of 3. All right. X of 1, Mia, Victoria. So we're here. 2, that is correct. 2 are white. Okay. That means that X of 2 is what, guys? 2. So that's 2 red. And what is X of 3? 1. Okay. But now we need its probability. This is where it gets interesting because this time they didn't give us a probability. But let's figure it out. 2 are white. Well, before looking at all that information, what is the original data? 4 white, 3 red, and 3 blue. What is the probability of a white ball according to this? Tell your neighbor. Probability of a white ball. Fernando. 4 out of 10. That is correct. 4 out of 10. Because the original box contains how many? 4, 3, and 3. The next one was, let's use 2 red. So what corresponds to red? What would be the probability of red? 3 out of 10. That is correct. And the probability of blue, everyone? 3 out of 10. And the rest is history. Substitute that into your formula and find me a probability, and I'll send you the screen. So with that said, from 1 to 5, how comfortable are you with this so far? Multinomial probability. Yeah, we got it. So here's your home plate for tonight. I'm going to give you a head start. There it is. Those of you that are following on YouTube, there's your practice. See you guys later. Bye.